systems who might pick units, i.e. every 10 minutes, take the temperature, or take every fourth person, blah, 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 blah. Okay. Sweet. Those same orders then. All right, and then there's convenience, and that's exactly what it sounds like. So if I said, I want to know what stats students think about this, so I'm going to ask you guys, isn't that convenient for me?
Yes.
Number one, you're probably going to do it because you're my students. If you don't do it, that's not going to look good for you. And number two, you're here. It's very easy for me. But is it representative normally? No. So standing outside of a music store and asking people what they think about recent awards and what they thought about who got what, that's convenient for you. Right? That doesn't really represent the entire population. If you want to know what California thinks about something, you're not going to get it just from the library. Right? It's convenient because they all come there and you're like, what do you think about this? Really? What do you think about this? It's very convenient, but it's not very representative. Exactly what it sounds like. Then we finally got these two. And these two I want to focus on to show you the difference between the two. Give myself some more room. Stratified and clustered. Stratified, if anybody has taken like a geology class or something, talking about the strata, you can see the different levels, the different of the layers. Cluster has its own connotations, but like the clusters in cereals, little clusters of things. But how the hell do they apply to sampling? Well, stratified and cluster, they both have the same first step. And actually, I just did one of these two just a minute ago when I broke it up into groups, because the first step for each one is break it up into groups. Break the population into groups. Break the population into groups. So that's what I did earlier. I did my rows, right? I broke you guys into groups. Or men and women, I broke you into groups. Stratified would take some from each group. Some from each. Some from all, right? Take some people or objects from each group. Whereas cluster would take all from some. So if I would have said rows, I'm going to take the second row and the fifth row. That would have been cluster. But the way I did it, I took one from each row. That's stratified, right? So in a situation where like you're in a high school and you want to put in the paper opinions from students, don't you want all the students to read that paper so that maybe they'll pay whatever they have to pay or whatever? Right? So aren't you going to talk to, if you have an opinion, you're going to talk to some freshmen, some sophomores, some juniors, some seniors. You're going to make sure that you get some from all, aren't you? So that's why you would have a stratified situation. Sort of like our government. Don't we have representatives from every single state? We don't just have the whole population of people that want to be, and then we just pick from them. When they all happen to live in Michigan. Ooh, Michigan has a lot of stuff being built now. What's going on? No. Right, so that's not how we do it. We want everybody to be represented, so we make sure that the groups are all represented. That's stratified. Take some from each. Cluster, take all from some. So if I had like 3 classrooms, let's say there's only 3 classrooms that have people in it right now. There's us, and there's people next door, and there's people, I don't know, is there one of them? The people next to them, right? It's the only classes going on today. Everybody else is sick. Stratified would say, take 5 from there, maybe 4 from there, maybe 6 from there. And normally you would do like more from the ones that have, like if we had a lot of students and next door they only had a few, maybe I take 6 from here, maybe I'll take 3 from there. It's called proportional sampling. You don't have to do that, but it's some from each. That's stratified, right? Cluster would say, all right, there's the 3 classrooms. Let me do this one and that one. So these 2, I'll take everybody, and nobody from here, right? And you might do it that way, like if you had to study the hospitals in California. You would randomly select entire hospitals and have them just shoot their entire patient information to you. It'd just be easier, right? Yeah.
It seems a lot less simple random, so how do you distinguish?
Gotcha. Random, all of these could be random. In fact, when I did that, didn't I say that's random? So you do the one that's more descriptive. If it's random, but there's a system to it, that's systematic. If it's random, but they broke it into groups and took 1 from each, that's going to be stratified, right? So each of these has a chance to be random if I do it well, but you don't call everything in the world random and go, well, Jeff, I can't be wrong. No, no, no. You do as descriptive as you can. If it's random, but they picked, 2 whole hospitals, left 1 out, that's cluster. You got to tell me cluster. Is this random sampling?
No, because the probability test doesn't have a chance.
They did have a chance, didn't they?
Yeah.
So this is random. Every single patient had a chance. I know now I picked 2, but they had a chance. Not everybody can win the lottery, but everyone that plays has a chance, right? So they are all possibly random, but don't have random as your answer for everything, right? If they start breaking it up into groups, it's got to be one of these 2. Cool. So let me give you a few to try here. I've been talking way too long. You guys agree? Maybe I'll put it up here in case you don't have your book yet. Let's see what I do. All right, so those of you with books, take a look on page 34. Let's actually look at page 35. Number 6. They want to know if it's observational or experiment. So a Gallup poll surveyed 1,018 adults by telephone, and 22% of them reported that they smoked cigarettes within the past week.
Observational.
And this is where I personally like the edition from before this edition, because they broke it down into 4 steps. There was observational, experiment, simulation, and survey. Because the survey is kind of weird, isn't it? Did you actually affect whether they smoked or not? No. But they could tell you, they could lie to you, they could change what they're saying because you're asking them. They could lie to you, right? They could always lie to you, though. Right? No matter what you do, they could lie to you. And there's actually entire classes, there's actually ways they can tell better if they want to trust data or not. So what do you think about that then? Let me see, it's over.
And it would be observational.
You didn't give them cigarettes, right?
Yeah, you didn't put a pack of cigarettes in front of them and say, "Are you gonna smoke these?"
Exactly. You didn't change what it is you're trying to observe. You didn't change that behavior, right? Now, imagine this. You go out and it's a little foggy and you're trying to tell somebody about what you're observing. Couldn't the fog interfere with what you're seeing? Does that make it experiment suddenly because of something? No. So the responses might alter what you're observing, but you're still not changing their behavior because you don't have a time machine. Did you smoke? Wait a minute, I'm there with you now. You know, no, put that cigarette down. Now you didn't smoke, did you? All right. There's no way you can change their behavior that you're talking to them about. So I would say that's observation. Number 7 is just evil. Whoa. This one is a good example of changing something by not giving something. So this is a true story. 399 black men with syphilis were not given a treatment that could have cured them. The intent was to learn about the effects of syphilis on black men. The subjects were initially treated with small amount, blah, blah, blah. Definitely. Now, some people argued they weren't given treatment, but wasn't the environment changed from what it would have been?
Yes.
Right. Good. So, in fact, you could do an experiment not giving water to a dog. It sounds terrible, but right? You don't give them something while you're altering their environment. What they normally would have gotten, you're changing it to see what would happen. So that's definitely an experiment. What about number 9 through 20? So this one's talking about the different types of sampling. Here, I love this one. Number 11, exit polls in the recent past have gotten a lot of attention. Right? I don't know, some of you guys were probably 9 years old back in, or 8 even, in the election of 2000. But exit polls got a lot of play then because some of them showed Gore winning and suddenly he didn't. And people said, oh, exit polls, you can't trust it. Well, look at on the day of the last presidential election, so voters were surveyed as they left the premises. So organized an exit poll in which specific polling stations were randomly selected and all voters were surveyed as they left the premises.
Convenience.
Was it convenient for them to select the polling, to get a list of all the polling stations, drive out to the polling stations? That was convenient.
Yes. No.
I want you guys to come out and mow my lawn because, you know, not much more work. That's not necessarily convenient, is it? Convenient would be setting up camp at the polling station near you without even trying to randomly select any polling stations. Sit down and say, what are you doing? And that's it. That would be convenient. What'd they do? Specific polling stations were randomly selected. It wasn't necessarily near them. All voters were surveyed as they left the premises. So that's all from some. Clustered. Good. Right? So they're broken up into polling stations. And all of them were taken from some of those polling stations. That's definitely clustered. Let's see. Number 15. This kind of thing is going to be pretty obvious. Federal Mogul Company, interesting, manufactures these spark plugs. Quality control. Every 100th spark plug is tested from the assembly line. Systematic. Every 100th one. What could be wrong about doing that with an assembly line?
Well, because you're only testing 1 in 100, so the one that you test could be fine, but then the other 99 could be crappy.
Yeah, there could be something in the machinery that every 100th one, I'm thinking like the other way around maybe, hopefully, like 99 of them hopefully aren't dead, but it maybe every 100th little thing is broken, and so when it stamps it on there, it doesn't do it correctly. So if I take every 100th one, I'm like, okay, that one's not working, that's okay. That one's not working either, okay. And that one's not working, oh shit. You know, I'm thinking things are really bad. So it's bad to use systematic sampling when there's something that might be repetitive in what you're studying. Do you guys see what I'm saying? So assembly line, I normally would not use systematic sampling. I'd want it to be much more directly random than that. Take the first one and the 8th one and the 9th one and the 28th one and whatever, right? Oh, I'm trying to find one. Let me see really quickly. Well, 18 is pretty straightforward. In a study of college programs, 820 students were selected from communications, 1,463 from business, 760 from history. The sound stratified. I had a student bring up a good point. Is that the only majors they have? Now be careful, you're going to the simple random because they were broken into groups, but that actually makes it definitely not simple random. This answer, I would definitely take stratified, number 1. That's what you guys said. But the thing I want